All right. Last round of Miss Brandel being out for this unit. So happy Friday, guys. So here are today's table of contents. If you have missed any of the days that I have not been there to glorify your presence, then you need to log on to Canvas and you need to look at the notes that you missed. And then 2, if you want to complain that you could not see stuff on this video, then you need to also go to Canvas because all of my notes are up there. So please get them if you do not have them, because you are going to have an interactive notebook check next week. So better catch up. Okay? So if you need any more time on table of contents, please pause this video now. This is our last lesson of Chapter 9. Your test over Chapter 9 is next Tuesday. The sub will be giving you the Chapter 9 review to work on. I would highly recommend writing it on a separate sheet of paper. You won't have room. So make sure you do that. And we will have time in class to work on it on Monday, but it is a lengthy review, so make sure you do that. Don't forget you have IXL assignments to do tonight at 11:59 p.m. and yes, I will pull those tonight. Trust me, I'm crazy. I will do it. Okay? So, please make sure you've done your IXL assignment and start on your Chapter 2 or Chapter 9 review this weekend, but you will have time in class to work on it Monday, test Tuesday. Okay? So, let's go ahead and get into it. This is our last set of notes for Chapter 9. So, Wednesday, I don't even know what day. Wednesday, we talked about linear versus quadratic versus exponential, what kind of behavior each has. Then yesterday, we talked about solving a system of linear and quadratic systems. So, where you're just doing it by graphing, seeing where it crosses through. And today, we're going to talk about quadratic regressions. So, we've already done regressions twice this semester. So you can go ahead and start copying this down. Page 52, 9.9, quadratic regression. We've done linear regressions, we've done exponential regressions, and now we're going to do with quadratics. The process is exactly the same as how the other regressions were, except that you're going to do a different regression. So as you see, we're going to do quad reg instead of lin reg and x reg like we've been doing. And it's going to pop out an equation in the standard form of a quadratic, y equals ax squared plus bx plus c. It's going to give you a, b, and c, and you just need to write those all in. So I'm only working through 2 examples because we've done this already this semester. Just this time it's going to make a quadratic equation instead of linear and exponential. So we've got this first set of data here. So we're going to treat months like our x's and sales like our y's. So we're going to do it exactly the same way we've done all regressions. Okay, so we're going to start by hitting stat. So stat is this button right here. So remember that nice little friendly button. We're going to hit stat. And I'm then going to hit enter. So remember, enter's all the way down here to select edit. So the first one. If you have stuff in your list like I have in mine, then you need to scroll up to where the list is selected and hit clear. Do not hit anything else. Okay? And scroll down, everything will disappear. We're going to do the same thing with L1. Scroll over to it, scroll up, hit clear, and scroll down. Everything's gone. So everything for my x's is going to go in L1. So let's do that. We've got 0, so you're going to hit 0, enter, then 1, enter, 2, enter, 3, enter, 4, enter, 5, enter. Okay, so that is everything that goes in L1. Then we're going to do the same thing with L2, so scroll over to L2 and then put all the y values, so the sales values. So 5.6, enter, 5.8, enter, 6.2, enter, 6.9, enter, and 7.9, enter, and 9.0, enter. Okay, so there's all my data. So, same process is the same that we've done with all regressions. We're going to hit stat again, so this guy, hit stat, and then we're going to scroll over to where it has calc up here. So scroll over to calc, and then we're going to scroll down till we see quad reg, which as you guys see is number 5 right here. So scroll down to quad reg, and you're going to hit enter until the screen changes, or you can scroll down to it and hit calculate. And so then it gives me all these values of A, B, and C and tells me what my equation is. So on all of these guys, I want you to round everything to the nearest hundredth. So that's the second decimal place for all these. So I'm going to side note these over here to help myself out. They tell me A is 0.12. That's how I'm going to round it. 0.12. B, we've got 0.069. That 9 makes this round up to a 7. So remember, you look to the right. If the right is greater than 5, you round up by 1. If it's less than 5 if it's 5 or greater, you round up by 1. If it's less than 5, you don't round at all. You just leave it as is. So since this is greater than 5, make that a 7. So 0.07. And then lastly, C, 5.596. 6 makes this 9 round up. If it's a 9, that means we need to take the next number and round it. So it's going to be 5.60. So 5.60, or you can call that 5.6. Okay? So those are all of my pieces, and it asks, find the best fitting quadratic model. So all that's asking for is the equation. So y equals ax squared, so 0.12x squared, plus bx, so plus 0.07x, plus my c, which is 5.60. So that would be my equation or my model. Then it asks, what is the prediction for total sales in September? Okay, so look back at our data. Our data is based off of months. Okay, and it says that this is for a new hair salon since its grand opening in March. So 0 has to be March. That's the starting point. So then that would make 1 April. That would make 2 May, 3 June, 4 July, and 5 August. So you have to ask yourself, what would that make September? So that would make September 6. So what I need to do now, since months was my x's, I need to just use my equation and plug in 6 for x into this equation up here. Then that'll tell me the prediction based off this model for my total sales. So we're just plugging in 6 in place here. So I'm going to get my calculator. So we're doing 0.12, and then it's x squared, so we're doing 6 squared. I would use parentheses when you're plugging in, so parentheses 6 squared. Okay? Then it says plus 0.07 times my x again, which is 6, then plus 5.60. So when I plug in 6 into my equation, I get 10.34. So 10.34, and that's thousands of dollars in sales. So remember, 10.34, let's say thousands of dollars. So just to be clear. Okay, so thousands of dollars in sales. Then this third question asks, how do you know that the better model to use a quadratic fit rather than a linear fit? Okay, so it asks, how do you know? So maybe something just to note here is it's not having a constant change, right? It's kind of like slowly increasing. And so if you think about it, maybe we can see if they've got these differences. Okay, so this one is going up by 0.2. This one's going up by 0.4. This one's going up by, a little close for room here, 0.7. This one's going up by 1. And this one's going up by 1.1. Right? 1.1. So maybe check those second differences. This is 0.2, this is 0.3, this is 0.3, and this is 0.1. So it's almost having a constant second difference like we talked about 2 days ago. So I would just say here, because this is not constant at all, it doesn't have a constant rate of change, which is what would make it linear. Okay, so that's the first example. So if you need more time to copy anything down, pause it now. I'm just going to work through one more. So example 2, this class did an experiment by rolling a marble down different length slanted boards and timing how long it took, and it has the results below. So automatically the first column or row you see, make that your x's and your other ones your y's. So seconds are x's, centimeters is y. They first ask us to plot the data, so we're going to do that. First I'm at 0, 0. Then when I'm at 4.5, so here would probably be, let's see, they counted by 3, so 4.5 would actually be this directly. I'm at 10. When I'm at 11, so that's going to be halfway-ish, somewhere in here between. Doesn't have to be perfect. I'm at, or I'm sorry, on this other side. I'm at 60. When I'm at 13.4, I am at 90, so it doesn't have to be perfect, just somewhere in between. And when I'm at 10, I'm at 50. When I'm at 8.9, I'm at 40. When I'm at 14.1, I'm at 100. When I'm at 9.5, I'm at 45. And when I'm at 12.6, I'm up at 80. So again, these don't have to be perfect. Okay. So looking at this one, to me this almost looks like this has more of a linear relationship if we're looking at these. So I'm just thinking ahead, like the same question we dealt with up here, is how do we know a quadratic's going to fit better? But think about it. Even though this is a line, it is curving out here, so it's starting to make kind of that U shape. So it has, I'm already going ahead and answering this question. So saying it has linear behavior for most of it, but not enough to be only linear. No, that's not the best fitting there. Okay, so now they're asking us, what is the quadratic curve of best fit? So we're going to do the same thing like we did above. We're going to put everything for the x's in L1 and everything for the y's in L2. So if you need more time to copy this down, pause the video now. So we're going to start back again, hitting stat. Oops, I hit delete. Stat here. We're going to select enter for edit. Going to clear our list, so scroll up, hit clear. Scroll down to make it go away. Scroll up, hit clear. Scroll down to make it go away. So x's go in L1, so the x's are 0, 4.5, 11, 13.4, 10, 8.9, 14.1, 9.5, and 12.6. So those are all my x values. I'm going to scroll over to L2 and put my y's. So my y's are 0, 10, 60, 90, 50, 40, 100, 45, and 80. Okay? So once you've got all those in, you can pause if you still need some more time putting them in yourself if you're wanting to do it with me. Okay? After that, you're going to hit stat again. We're going to scroll over to calc and scroll down to quadreg. Hit enter until my screen changes. And here are my values of A, B, and C again. So you can pause this if you want to look at that a little longer. But I'm going to write those in this space they provided for me to plot the data, which I did over here. So A is at, we're going to round to the hundredths. So 0. I'll let you look at that. 0.50, but look to the right. We've got a 7, so we've got to round up. So 0.51. Okay. B, negative 0.078. So looking to the right, we've got an 8 there. That makes me round that 7 up to an 8 as well. So negative 0.08. So now when I use C, 0.03, look to the right, there's a 5. So I have to change that 3 to a 4. So 0.04. Okay? So, making my equation, plugging all of those in, y equals my a, which is 0.51, x squared, minus 0.08. The reason I said minus is because this is a negative. Normally it's just plus bx. So make it minus 0.08x plus my c, 0.04. So that is my equation. Now the next two are asking me to use my equation to figure some things out. So based on the graph, how long would it take for the marble to roll 15 centimeters? Okay, so think about this. Let's talk about centimeters. Okay, so centimeters are my y's. So how long is it going to take for me to get